Okay, in this video, we're going to have a look at how we can get seawater and how we can make it so it's suitable for us to drink so that the water is potable. Okay, so it's done in a couple of different steps in order to do this. First thing we need to do is we can collect the seawater and we can evaporate it. And we know from our experiments in class that evaporating seawater would leave any of the salts that seawater contains behind. Once that's evaporated, we then need to condense the steam that forms, so condense the steam. And once we condense it, condense means we're going to change it from steam to from a gas to a liquid, so we start to form our water again. At this point, the salt will remain inside the seawater. So salt will not travel with the steam. So salt will remain in the seawater. Okay. Just as an extra precaution to make that water super safe for human consumption, we would then add chlorine, which will kill off any microbes, bacteria before we use it. So the water is then chlorinated for extra safety, just to make sure it's going to be safe for consumption. This process is used by cruise ships. So cruise ships would need to make water as they travel, and obviously surrounded by seawater, so it's a way for them to do it. It also happens in warm countries where there's a low level of rainfall, and they can do this process as well in order to get fresh water. Interesting, I've got a little picture here that I've added just for reference for you. So you can see, here's your seawater, which has been heated. This evaporates, so that steam comes up through here, through the condenser, and in the condenser this will be surrounded or made to be cold to help that condensation happen. So we start to get our liquid forming, and this liquid water is going to contain none of the salts that sea is here. So this is fresh water, and we'd add the chlorine to this in order to ensure it's safe for humans. Okay, in this video we're going to have a look at how we can make drinking water safe if we obtain it from rivers and lakes and reservoirs, and what steps we have to put that water through in order to have that water ready and safe for human consumption. So as you can see here, the water that comes through is going to contain all kinds of substances in there. It's going to get sand and grit and leaves and twigs, and we're also going to get other chemicals in there as well. So pesticides from farms run off into them, fertilizers, and then we get bacteria and other microorganisms that could be harmful to humans. So how do we go about preparing that water so it's safe for human consumption? Well, a couple of things that we do, as you can see in this diagram, is we take it through a series of steps. So the water comes in from our source, and we have this sedimentation tank. And sedimentation, what this means we're going to do is allow any of those larger particles to settle out and sink to the bottom. So sedimentation is taking the larger insoluble particles, and they just start to settle. So the larger is allowed to settle, and they will start to settle at the bottom here. So you get this layer at the bottom that can just be taken away. Once that's happened, we then put it through a filtering system. So the water will come into the filtering tower, and you see it's going to pass through some different layers. We get a sand layer and then a gravel layer. And the idea is as water passes through those layers, that is just literally going to filter out any other substances in there to remove it from this process. And then once it's gone through this filtering process, it then comes into one of the final stages before being ready for use, which is where we add chlorine. And the chlorine is added because that's going to kill bacteria and microorganisms, and that will make the water then safe to go off, ready for homes and for use. So it's stored in a tank before being sent off for use by public. So a couple of different steps. In short, 3 steps. So we get our sedimentation, our filtration, and chlorination, and those 3 steps happen in that order in order for the water to be prepared for human consumption. Okay, in this video we're going to have a look at the type of water that scientists would use to carry out any kind of analysis in. And if we're going to carry out any analysis, we need to make sure that the water we're using does not contain any dissolved substances. If the water has dissolved substances in there, they could interfere with the analysis and therefore give us results that are not accurate. Okay, so that I'll write in here so we've got it as a reference point. So we can say the dissolved substances could interfere with results affecting the accuracy of the analysis. And we wouldn't want that to happen. For example, if we were analysing a sample for calcium ions and the water already had calcium ions present, then that would interfere with our results. In order to get water that is good to use, we have to remove these dissolved substances. And the way we do that, as we've talked about in class, is we would go through a process of fractional distillation. And the fractional distillation is, remember, it's a two-step process. We are going to boil or evaporate the water and then condense. So we're going to boil and condense the water to remove the dissolved substances in them.